Okay, so we're given a systems of equations. This means that we have two different equations, and we're looking to solve for both variables x and y. In order to do this, we need to combine our equations to only have one variable, because right now we cannot solve for x or y in either scenario because there's two variables. So here we can think about using substitution because we have an x equals 2y minus 15, and we can literally substitute that x value into that equation, negative 5x plus 4y. So if we have the equation negative, I'm just going to rewrite it. Negative 5x plus 4y is equal to 3. We can literally take x and substitute it in here to this part of the equation. So we're left with negative 5 times, and I'm going to put it in parentheses. In place of x, we're literally substituting what x is equal to. So since these two parts of the equation are equal to each other, we can replace them for one another. Plus 4y is equal to 3. And now I have, after I've substituted in, I now have an equation that has only one variable, and now we just need to solve for that one variable y. So here, I'm going to use distributive property. Negative 5 times 2y is negative 10y. Negative 5 times 15, a negative times a negative gives us a positive. So negative 5 times 15 is positive 75 plus 4y is equal to 3. I'm going to draw the wall around my equal sign. This is going to help me see that on the left-hand side, I can combine like terms with negative 10x and 4y. So the negative 10x plus 4y leaves us with negative 6y plus 75 is equal to 3. Now we need to use inverse operations to get our constants on one side and our variable on the other. So we're going to subtract 75 from both sides. The inverse of addition is subtraction, so negative 6y is equal to negative 72. And now we're going to do the inverse of multiplication, which is division. So we're going to divide by negative 6 on both sides. A negative divided by a negative is a positive, and we're left with y equals 12. So this is one of our variables. But now we can take this variable, so we solve for y. But now we also want to solve for x. So I can come back up to these equations, and I can choose either equation I want to substitute y back into that equation. So I can do equation 1, I can do equation 2, but equation 2 looks a lot more simple. It's going to involve less steps, and it already is already set up with x is equal to something. So we have x is equal to 2y minus 15. So because we're already set up with x equals, it would be advantageous to use this. So we have y is equal to 12, and I'm going to take that and literally just substitute it in here for y, and this is going to give me the value of x. So x is equal to 2 times 12 minus 15. So x is equal to 24 minus 15, and we get that x is equal to 9. All right, and now we can take our x and y, and this is our solution, and we can write it as 9, 12. So if I wanted to graph these two lines, I would get a solution of 9, 12.